So in the previous video, we actually looked at how to conduct ANOVA for 4 different food delivery services, which is DoorDash, Uber Eats, Skip the Dishes, and Foodora. So we had 20 observations on each of these on the delivery times for each of these services, and we ended up conducting an ANOVA single factor ANOVA, and we ended up rejecting the null hypothesis that the means were equal because the calculated F statistic is greater than the critical value of the F statistic. So this leads us to the next question and let's say that in case you're interested in comparing the differences between Uber Eats and Skip the Dishes. So if you want to do a separate comparison, again, remember when you collect observations together, this is an additional inference step only if you reject the null hypothesis using the F test. If you do not reject the null hypothesis using the F test, and if you conclude that the means are all similar, then you do not proceed to this step right now. So this step includes the fact that so once you reject the null hypothesis from your F test, you could move on to testing 2 separate parts using an additional test, which is known as using the confidence interval method. So here we use the Uber Eats and Skip the Dishes. We are going to use the confidence intervals to try and test if the means for these two are similar, or if one is greater or one is lesser. Remember, from the earlier means, we did find out the mean for Uber is 13.25 and the mean for Skip the Dishes is 15.6. However, the variance for Uber is a little bit greater than the variance for Skip the Dishes. So using this information, we are going to try and test if Uber Eats delivers food a little bit faster than Skip the Dishes. So let's go ahead and actually compute that value. So the test statistic for that is going to be, or it's not a test statistic, we will be using the t-test statistic, but we will be computing, answering our question if one is lesser than the other, or Uber Eats is lesser than Skip the Dishes based on this confidence interval. So this confidence interval formula is given you by the differences x1 bar minus x2 bar, where 1 is Uber Eats and 2 is Skip the Dishes, plus or minus the critical t-statistic value into the square root of the mean square error, and you're adding the sum of the observations, 1 by n1 plus 1 by n2. So this gives you 2 values. First one using the negative value, which is the lower bound, and the second one is using this positive sign, which is the upper bound. And if both of these are positive, that means the difference is actually greater than, so x1 is greater than x2. If both are positive, you get positive values for the lower bound and positive values for the upper bound. That means the mean, the x1 bar is going to be greater than x2 bar. And if one is negative and the other is positive, this means, you cannot reject x1 bar is equivalent to x2 bar. And this is the null hypothesis that the means are actually similar and they are not very different from each other. But if both of these bounds are actually negative, you could say that x1 bar is actually less than bar. So these are your inferences based on whether 0 is actually included in the confidence interval or not. So if 0 is not included in the confidence interval, you could conclude that it's either this or this, and depending if both values are positive or negative, you could conclude the particular direction. So we will be using this method to actually apply this for our food delivery service problem. So we have the Uber Eats and we have the means, and we could compute the test statistic is going to be the t-test statistic with n minus k degrees of freedom. So here, if you remember, we have 40 observations in our sample, and the degrees of freedom is going to be n minus k, which is 2.028. Okay, and if you use 20 observations of the sample, our critical value is going to be 2.093, and that will be our critical value there. So once we use this test statistic, we could go ahead and actually compute the value. So the confidence interval is what we need to compute, and this confidence interval is actually given by this formula. So x1 bar minus x2 bar So I did go ahead, and the mean square error is found out from the mean square error which you calculated in the previous step. And using that mean square error, and the 1 by n1 plus 1 by n2 is actually equivalent to 0.2. And once you have these values, you can calculate the lower bound as the difference between two values. This here, the difference between the two values is going to be 13.25 minus 15.6. Yes. So that'll be the difference, 1 bar minus x2 bar. So x1 bar minus x2 bar is negative 2.35. The t statistic is given. This could be included as 2.09 if you need to, or and the mean square error is calculated as what we calculated before from the previous table. 1 by n1 plus 1 by n2 is calculated as 0.2, and this n1 and n2 are both 10 for, or actually 20. Sorry, my bad. So 1 by n1, so it'll be 1 by 20 plus 1 by 20, so that's going to be 2 by 40, or that's 1 by 20. Okay, that's going to be 0.05, and this gives us a lower confidence interval. This x1 minus x1 bar minus x2 bar minus the t statistic into the square root of the multiplication of these MSE into 1 by n1 plus 1 by n2. And that will give you a value of negative 3.56. And the upper level of the confidence level, the upper bound of the confidence level, is also a negative value over here. So here we could, since both values are negative, we could conclude that x1 bar is actually less than x2 bar. Or here, the mean for Uber Eats is definitely less than the mean for Skip the Dishes. So this is our computed value, and this is an additional inference which you can find out using the mean square error value in your future test. And this is your learning objective 11.3.